everyone, welcome back to another exciting video. On way to programming, today we have another topic related to Python programming. Today we're going to talk about dynamic and static values in Python. So uh, let's jump right into it. First, let's explore dynamic values in Python. What are dynamic values, right? As the name suggests, these are dynamic. So they are flexible, right? And they also make Python programming versatile. Okay. Now let me give you a quick example related to dynamic values. And just know that in Python, dynamic values are also called variables, right? So these are the values whose data type can change during runtime. This means that you don't have to declare the type of a variable explicitly, right? Now let me give you an example. So let's say I have a variable, I'm going to call it my variable, and its value is 42, right? So integer value. I can print this value, right? So I'm going to say my variable, and the value will be printed on the screen. I can change this value. So variable is the same, my underscore variable. I can change this value to a string also. So if I say hello world, and now if I run this print statement, the value is changed, right? So initially I assigned an integer to my variable, and then without any fuss, I changed it to a string, right? So Python handles this seamlessly. Why? Because of its dynamic typing. Okay, now let's talk about static values. So unlike dynamic values, static values are prevalent in languages like C++ and Java, right? So in these languages, you have to declare data type of a variable before you can use it. And In languages with static values, you will also encounter strict type checking, which means you need to, specifically write the data type up front, which also provides a level of safety. If you can easily catch type related errors at compile time. Okay. So now I hope you understand the basics of dynamic and static values. Now let's discuss the pros and cons of each approach in Python. Okay. So first let's talk about pros of dynamic um, values, right? Let me, okay. So let's talk about pros of dynamic values. The number one pro or benefit is flexibility, right? Dynamic typing allows you to write code more quickly and adapt to changing requirements. As you can see, I didn't have to think about the data type of my underscore variable, right? So I wrote it very quickly, and when I wanted to change it, I could easily change it, right? So the values are easily, adaptable. They're easily adapting to changing requirements, and you don't really need to explicitly specify the types. So it also reduces some headache, right? You are not worried about it, and it also improves readability of the code, right? So code often reads more naturally in Python. It is less cluttered with type declarations, because if I'm declaring the types, user will have to read the types also, user will have to understand the data type also. But here it is more readable. Why? Because when I assign the value 42 to my underscore variable, user knows that it's going to be an integer value. When I assign a string, user knows that it's going to be a string value. So these are some of the benefits of uh, dynamic values. But at the same time, there are some cons or drawbacks of using these values. Number one drawback is runtime errors, right? So if it is a type error, right? Type errors are usually caught at runtime only, right? So it can be more challenging because these types of errors are caught during runtime. user will have to run the entire code. Then only they will be able to find runtime errors. And because of that, it introduces, some sort of overhead, right? So it makes Python slower compared to statically typed languages in some scenarios. So let me give you an example how it can lead to, runtime errors. Okay. So I'm going to create a function here. I'm going to create a program, uh, and I'll try to illustrate how, there are, it's just going to be an example of potential runtime error. So let's say this is the function that I have, a comma b, right? And we are returning a divide by b, divided by b, right? Okay. So now let's call the divide function with some inputs. I'm going to take another variable result, and I'm going to call divide function with some inputs, let's say 10 and 2. And now we're going to print the result. Um, okay, so that's one thing. Now let's call another one. Result equals to. So now I'm going to change the values to 10 and 0. Okay, and I'm going to print, I'm going to try. Okay, let me save this number. So let me call it program example. Okay, now I will run it. Okay, do you see? So for the first statement, where is the program? Yeah, for the first not statement, like when I call call the function divide first time, this is the result 5.0. But when I call it for the second time with values 10 and 0, I get an error. This is the error, right? What is the error? If you can see, it's zero division error, division by zero error. Okay, one more time. In this example, let me show you the example. So we have divide function. It is taking two arguments, a and b, and then we are calculating the division, a divided by b. In the first call is calculating the division. In the first call to divide, I'm using two values 10 and 2. There is no issue and the result is calculated correctly. However, in the second call, divide 10 comma 0, we are attempting to divide by 0, which is not allowed in mathematics. This will result in a potential runtime error because Python does not catch this error at compile time, right? So instead, it is raising uh, an error, zero division error, right? Zero division error. This error is being raised. Okay, now this demonstrates how dynamic typing in Python allows us to perform the operation without knowing the types of A and B beforehand, but it can also introduce the risk of potential runtime errors. And that needs to be handled through, careful coding and error checking. Okay, so these are some of the cones of dynamic values. Now let's talk about static values too. Um, So for static values, if I have to talk about pros first, obviously, errors can be detected early on, right? Type errors are caught at compile time, so it reduces chances of runtime crashes, just like it happened in this example. And then that results in faster execution of code. It enhances the tooling. IDEs can provide better auto completion and error checking due to explicit type information. If we have to talk about cones of static values, well, a code becomes more complex. As I mentioned earlier, there are many declarations, so development will be slower because you have to write and maintain code with explicit types, right? code will be less flexible. So if you ask me which one is better, dynamic or static values in Python, well, I would say it depends on your project's specific needs and your personal preferences. Dynamic values offer flexibility and reliability, but static values provide early error detection and they also provide improved performance. So it's all about finding the right balance for your project.